Equipotential surface or lines. When the value of electric potential remains constant throughout the surface or lines, it is known as equipotential surface or line. For example, here these are lines of equipotential surface, because on this line everywhere potential is same. That if we, for example, on this line at this point or this point or this point or this point, potential will be 20 volts. Similarly, this line is a equipotential line. Here every point have a same potential, that is we can write Vc equals to Vd equals to 30 volt. Similarly, for other lines are similarly, here it is shown a equipotential circular line or a spherical line. Here if we consider line that it is circular line, on that is in this circumference everywhere potential will be same, that is Vp1 is equal to Vp2 equal to 20 volt. Similarly, P3 P4 have same potential, so V4 Vp3 Vp4 equals to 30 volt, and Vp3 and Vp7 Vp6 is 40 volt. So this is the equipotential line, circular line. Here in this case a surface, equipotential surface is shown, that is on this surface every point have same potential. For example, at point P, at point Q and at point Q R, there will be same potential of 20 volt, that is we can write Vp equal to Vq equal to Vr equal to 20 volt. Similarly, in this surface T, U and S have same potential 30 volt, or we can write Vt equal to Vu equal to Vs equal to 30 volt. So these are equipotential surface. If a charged particle goes from one point to another on equipotential surface or line, the work done is zero. This is the important point, that is equipotential on equipotential surface or line, work done is equal to the zero when charged particle goes from one point to the another point on a equipotential surface or line. Or delta W equals to Q into delta V, because potential is not changing on equipotential surface, so delta will be V will be equals to 0, so whole will be 0 because Vf and Vi is same, since Vf equal to Vi. Next point, the electric field is directed perpendicularly to the equipotential surface and direction is from higher potential to lower potential. It is also an important point, that is if we have equipotential surface or line, then electric field will be perpendicular to that line and will be directed to the higher potential to lower potential. Here it is shown, for example, this is 40 volt line, this is 30 volt line, this is 20 volt line, and this is 10 volt line. So line coming from left to right, the potential is decreasing, so electric field direction will be from higher potential to lower potential, and electric field lines will be perpendicular to every line. So this is perpendicular, this is perpendicular, this is perpendicular. Here again we can see that this is 40 volt, 30 volt and 20 volt, so line will be from higher to lower. So electric field lines will be like this and will be everywhere perpendicular to the line. So every line is perpendicular to the equipotential surface or line. Same case is here. Here electric field in outward direction, because potential is decreasing in outward direction, in a radial direction. Here it is 40 volt, here it is 30 volt, here it is 20 volt. Next point is there is a different equipotential surfaces for single charge, or if we have a single charge, then maybe many equipotential surface for that charge. For example, if consider it is a point charge, then every sphere surrounding it will is a equipotential surface. So For example, this sphere is a equipotential surface. On this sphere, everywhere will be potential equal. Similarly, this sphere is a equipotential surface at the distance r2, and everywhere on this surface potential will be same. Similarly, this sphere is a potential surface, equipotential surface, and everywhere on this. Similarly, several spherical may be formed. So point charge equipotential surface with concentric spheres. Similarly, this is a line charge. So here will be every cylinder will be a equipotential surface. There may be infinite number of cylinders surrounding this line charge. So equipotential surface are concentric cylinders. Now, next point is that the magnitude of electric field is given by E equals to delta V by delta R, where delta V is the potential difference between any two surfaces and delta R is the perpendicular distance between the surfaces. It is for magnitude. If we have to find only magnitude, then we can use this formula only. We take the potential difference between two any surface, mode of potential difference and mode of distance between them, and then this distance should be perpendicular. Okay, then we can calculate the electric field in the region. For based on this concept, some problems are here, we can solve one by one. The first problem is find the electric field. The figure is shown here, and electric field lines are or surface are shown here, and angle this is x-axis. X-axis is making angle 60 degree with every equipotential lines, and the value of potential is given, that is it is 10 volt, 20 volt, 30 volt, 40 volt. So from the concept it is clear that the electric field will be here in this region from in this direction, because potential is decreasing in this direction, and we know that potential electric field always from higher potential to lower. Direction of electric field lines is always from higher to lower potential. And now another concept is here that electric field lines must be perpendicular to the equipotential surface or lines. So on this line we have to draw the perpendicular so that it show the electric field. In solution it is shown here. This is, we have drawn a perpendicular line, and this perpendicular line is the electric field lines, and also direction is shown because it is at higher potential, it is at lower potential, so direction will be in this direction. And because this angle is given from x-axis, it is 60 degree, so it must be 30 degree to make it perpendicular, that is 90 degrees. Now we can solve Ex equal to minus del V by del X, or we can reduce to minus VV minus VA, choosing only any two lines or surfaces, equals to XV minus XA, or minus of 30 minus 40 divided by 20 by 100 minus 10 by 100 equal to 10 by 1000, or 100 volt per meter. So electric field is 100 volt per meter. But the electric field is along AC, so Ex is equal to E cos 30 degree. So we can write E equal to Ex by cos 30 degree, and we have calculated the value of Ex. Value of Ex, so 100 by root 3 by 2 equal to 200 by 3, so E will be 200 by root 3. And direction will be at minus 30 degree with the x-axis. This is a direction because it is in this direction, so it will we have to take negative, and if in this direction there will be positive, or 330 degree with x-axis, both direction will be asked. In vector form, we can write E vector equal to E cos 30 I cap plus E sin 30 of minus j cap. So 200 by root 3 into root 3 by I cap minus of 200 by root 3 into 1 by 2 j cap. Solving, we will get 100 I cap minus 100 root 3 j cap, and also we have calculated here 100 Ex, that is X component of electric field as 100, and here also we find 100. And the magnitude will be given as mod of E vector equals to under root 100 square plus 100 root 3 to the square, 100 to 100 under root 1 plus 1 by 3, 100 under root 4 by 3, or 2 into 100 by 3, or 200 by root 3 answer. Now second method also we can use E equal to directly here we can find the magnitude. Mode of delta V equals to mode of delta R, that is perpendicular distance. Here we have to use the perpendicular distance. So here perpendicular distance will be mode of AC. This distance is perpendicular here. Here this distance A to C, that is this, we have drawn a perpendicular at A. So this distance is perpendicular. AC is perpendicular. So we have a mode of 30 minus 40 by mode of AC at 10 equals to AB cos 30 degree, because AB has given, AC is not given, and AC will be equal to AB cos 30. And putting the value, we have 10 by 20 minus 10 by 100 cos 30, 10 by 100, 10 by 100 into root 3 by 2, or 200 by root 2. So electric field we have calculated 200 by root 3. So we see that we can use any method to calculate electric field, and direction again will be minus 30 degree with x-axis, or 330 degree with x-axis. Find the electric field in the given figure A and B. In A, this is 20 volt, 30 volt, 60 volt. As potential is decreasing radially outward, so the electric field is radially outward, and E equal to mode of delta V by delta R, and mode of 30 minus 60 by mode of 2 by 100 minus 100, 10 by 100, 30 by 10 into 100 Newton per coulomb, or 300 Newton. सही तो है सेकंड मेथड. और सेकंड मेथड ER वेक्टर की माइनस डेल V विद AR इंटू R कैप, और माइनस 60 by 2 by 100 minus 100 by 100, और सोल्विंग we get 300 R cap in Newton per coulomb, or 300 Newton per coulomb along increasing in radius, and the B can be solved. We have E equal to mode of delta V by delta R, mode of 10 minus 20 by mode this distance AC, or 10 by AC is equal to AB cos theta, AB cos 60, 10 by 2 by 100 minus 10 by 100 into 1 by root 2, or 10 into 100 by 10 equals to 200 Newton per coulomb. Direction is 120 with x-axis. AC beta AB equal to cos 60. So AC, so AB cos theta. Now value of AB is equal to 20 minus 10. So 20 by 100 minus 10 by 100 into and cos 60 equal to 1 by 2. So next problem is our second method. We can solve this by also second method. Second method we have Ex equal to minus dV by dx or equals to minus of Vv minus Va, Vv minus Va by Xv minus Xa, or minus of 20 minus 10 by 20 by 100 minus 10 by 100, or minus 10 by 10 into 100 minus 100 Newton per Coulomb. Now also Ex equal to E cos theta. So E equal to Ex by cos theta minus 100 by cos 120 or E equal to minus 100 by minus of sin 30 equals to 100 by 1 by 2 equal to 200 Newton per Coulomb. So Ey equals to E sin theta, 200 into sin 120 or 200 into root 3 by 2, 100 root 3. Hence E vector equal to x I cap plus Ey j cap minus 100 I cap plus 100 root 3 j cap. Note Ax equal to A cos theta and Ay equal to A sin theta. If it makes angle theta with x axis, then we can write A vector equal to A cos theta I cap plus A sin theta j cap and Ax into I cap plus Ay into j cap, and theta should be angle made by positive x-axis. Consider the electric field is due to the charge q placed at center. Then V1 will be 1 by 4 pi epsilon naught q by r1, or q equal to 4 pi epsilon naught V1 r1. Hence EP will be 1 by 4 pi epsilon naught q by r square, or 1 by 4 pi epsilon naught 4 pi epsilon naught V1 r1 by r square, or V1 r1 by r square. Solving we get 6 by r square Newton per Coulomb or volt meter.